All right, so number 13, again, I want to practice with synthetic division. It's kind of leading you to that. So the number we're plugging in is -2. Okay, you can do it with a calculator, you can do it by hand. Now, with synthetic, you have to make sure you're not missing any terms. And what I mean by that is you take your biggest degree, which is a 4. If you compare all these, they're in order. 4 is the biggest, and you have to count down all the way to 0 in order. So we got a 4, and then exponent of 3, exponent of 2. I'm missing exponent of 1. I'm missing the single x, and then this 2 has 0, has no x. So if you're missing a term, you have to put a 0 as a placeholder. So remember how we listed the coefficients. The first one is 5, and you put them in order. And then the next one is 6, is +6. And then 3, because of +3. Now we're missing the single x term. We don't have a number with just x with no power. So I have to put a 0 there in the place where that single x would be, and then the last one would be a 2. And then the process is always bring the first one come straight down. And then we just multiply and combine all the way across. So -2 times 5 gives me a -10. Combine these, we will subtract because they're different. That will give me a -4. And then -2 times -4 gives me a +8. Add these because they're positive and gives me 11. -2 times 11 gives me a -22. Add it to 0 is still -22. And then -2 times -22 is a +44. Both positive add, we get 46. So our answer is 46. It's pretty nice just to multiply and add all the way across and get there pretty quick, versus raising something to the 4th power, 3rd power, 2nd power. It might take a little bit of time there, but we get 46 by plugging in -2. And this is a look ahead at synthetic. And then 14, we have an application. So we have this biology experiment given by this function, and they give us the function here, and t is the number of hours, and we want to determine how many of these protozoa after 5 hours. How many would we have after 5 hours? So we're going to plug in a 5 to this experiment. Okay. So with the decimals, it might be better to just see it on the calculator. So let's use that method. We're going to pull up our calculator, and we're going to input this equation. I don't think we're missing anything. Okay. Turn it on, y equal. Clear out what we have, and we're going to do 0.02x. Now the calculator takes the variable x, even though it has a t. Just use x, the same result will happen. So to the 4th, and then 0.4 x raised to the 3rd, and then plus 6 x squared. Alright, we're going to do second graph to see the table, and we're going to go to number 5, and we get 212.5, and it says round to the nearest whole number. So this 212.5 is what we got. P of 5 is equal to 212.5, and this would round up to 213. So nearest whole number we're going to say is 213. And then part 2, we want to know how many of these protozoa are present after 2 days. We're going to round your answer to the nearest whole number. So they're showing you 2 days is 48 hours. So we want to know 48. So you can arrow down, which will take some time to get to 48. Or you can do second and then this window button for table set. And we can just tell it to go down to 48. Tell it to start at 48. And then from here we do second graph to see the table, and it will be showing us 48, and we get a really big number. That's 16, 42, 29.